The complex plane. Why we need complex numbers. Some equations, like x squared equals -1, have no real solution, since no real number squared gives a negative result. Think about it. If you do 3 times 3, that gives you 9. But also, -3 times -3 gives you 9. You simply can't multiply a real number by itself and get a negative result. To extend our number system, mathematicians defined a new number. They called it I, and it's equal to the square root of -1. Therefore, I squared is -1. So we have something which, when multiplied by itself, gives a negative result. We call it the imaginary unit. The definition of a complex number. A complex number is any number of the form z is equal to a plus bi, where a is the real part, written re-z, and b is the imaginary part, written im-z. In this, a and b are real numbers. So this part, just a, is completely real. This part here is completely imaginary. So we have a number that is part real and part imaginary, and that's what a complex number is. The set of all complex numbers is written C, and it really appears to be the last set of numbers, going around the set of reals, which contains things like the rationals, which contains the integers, which contains the natural numbers. Representing complex numbers. Every complex number z is equal to a plus bi can be written as the ordered pair ab. If we plot all such pairs on a set of axes, we get the complex plane, also called the Argand diagram. The horizontal axis is the real axis. The vertical axis is the imaginary axis. Each complex number can be shown either as a point at AB, so we can put that point here, say AB, or as a vector from the origin O, 0, 0 to AB. So, in other words, a position vector, like so. And that's shown again down here. We can see the point AB, and then we can see the vector representing A plus BI. Key idea. The complex plane is just like the Cartesian plane, but the vertical axis represents imaginary values instead of y values.